Good morning. Today we are going to be reviewing Unit 3, starting with PO20 and going up to 28. We will be doing the practice test tomorrow and the real test on Wednesday. Remember those Khan Academy assignments that were due before Thanksgiving. Some of us did not get those done. Today is the last day for doing missing assignments. And if you ever have a Khan Academy that you take care of missing assignments on, you have to email me so I know to go recheck your grades so I can update Blackbaud. Khan Academy does not tell me when you do past assignments. You have to tell me. Math packet number 2, remember, is due, or math packet number 4 is due on Tuesday. You can turn it in today, turn it in on Tuesday. That is a first trimester grade. Our Unit 3 test is a second trimester grade. Still no? Okay. Our Unit 3 test will go on as our first grades for trimester 2. So we will have a chance to do retakes on those. What we want to do our best that we can on the test the first time around. So we want to, as we do the review, be filling out our help sheet. We can use the help sheet on the test. Remember, we do not do examples, but we can do definitions. We can do the rules. We can write things out that will help us. Marina, I need you to stop. Okay. I'm actually in the lesson now. All right, so let's look at PO20. On your help sheet, you would write PO20, and then you're going to actually write out all these rules from PO20. Rules on how to know if it's divisible by that number. Who can tell me what's the rule for 2? Layla. It's an even number. 2, 4, 6, 8, 10. So if in the ones place you see a 2, a 4, a 6, an 8, or a 0, if that is in the ones place, you know it is an even number. It is divisible by 2. So in the ones place, if we have a 2, 4, 6, 8, or a 0, what is the rule for if it's divisible by 3, Zelda?
If the sum of the number's digits is divisible by 3.
So if the sum of all the numbers in the digits is divisible by 3. Oops, by 3. So if our number was 215, we would add up 2 plus 1 plus 5. That equals 8. 8 is not divisible by 3. So we know right there, not divisible by 3, because we added up all of the numbers in the digit, we added up all the digits in the number, not divisible by 3, or is divisible by 3. So that's one where we have to do the adding. How do we know if it's divisible by 4? Madison.
If number can be divided by 2 plus.
So if your number can be divided by 2 twice. So first of all, that number needs to be an even number. It needs to be divisible by 2. Then you divide it by 2 and say, can that number be divided by 2? Is it even or odd? So in order to be divisible by 4, you have to divide it by 2 times. So if it's not an even number, you know right away it's not going to be divisible by 4 because we can't divide it by 2. But if we have a number like 50, if we divide 50 by 2, half of 50 is 25. 25 is odd, so we know it's not divisible by 4. It's just divisible by 2. How do we know if a number is divisible by 5? Layla.
If the number ends in
If the number ends in 0 or 5. So in the ones place, we have a 0 or a 5. We know it's divisible by 5. How do we know if it's divisible by 6? Madeline?
2 and 3 plus.
Yeah. If numbers is divisible by 2 and 3. So it's an even number. You add up those digits, it's divisible by 3. So if you have a 2 and a 3 listed as divisible, you know it's divisible by 6. Because 2 times 3 equals 6. Madison?
Oh, are you able to use a calculator on this?
Not this objective.
But are we going to be able to use it on the test for other objectives?
Yes.
Okay.
So just the beginning part, no calculator. If I remember correctly, it's the first sheet, we tear that off, turn it into me, and then the rest of the test, you can use the calculator. Because, yeah, if you're using the calculator, you're not showing that you know the rules. So we have to be able to show that we know. How do we know it's divisible by 9? Jimena?
If the sum of the number of digits is divisible by 9.
Yep, so just like with the 3, you add up those digits and see if that sum is divisible, this time by 9. So it's the same thing that we were doing for the 3, adding up all the numbers in our digit and seeing if it's divisible by that 9. Miss Gregory. How do we know if it's divisible by 10? This is an easy one. Zelda?
If the number ends in 0.
The number ends in the 0. So you can have all of the rules on your note card. You cannot put examples like I did here. No examples, but you can have the rules written out. So that way when it comes time for the test, we know there's going to be a whole objective for us saying, is it divisible by these numbers? You use the rules, okay? Put them on your help card. If you did not finish putting them on the help card now, you can go back and finish it later, but we need to move on. So let's look at 21. I can identify prime and composite numbers. So we need to know what is a prime, what is a composite number. Who can tell me the definition of a prime number? What is a prime, Layla?
It's a number whose factors are the sum of one factor
So, prime number is a number whose only factors are 1 and itself. We cannot divide it by any other number, not evenly. 1 doesn't count as a prime because we can't use 1 and 1 as itself. It has to have 2 factors. 1 only has 1 factor, 1. 2 has 2 factors, 2 and 1. 2 times 1 equals 2. Can't divide it by anything else. 4 has more than just 4 and 1. We can divide it by 2. So if you can divide it by more factors than itself and 1, it is not a prime number. So remember, 2, 3, 5, 7, 13, 17, those are prime numbers that we can't divide by anything else. But when we think about multiples of number, 12 is multiples of 1, 2, 3, 4, 6, 12. Lots of factors go into 12. Not a prime. We call that a composite number. So the composite number is a number with more than two factors. So if it's not prime, it's going to have more than two factors. So it is a composite number. You need to be able to use those rules of divisibility from PO20 to be able to say, oh, it's divisible by 5. Oh, it's divisible by 3. So I know it's a composite number because it has other factors to it besides itself in 1. If you can't divide by any of those numbers, then it's going to be a prime number. Ava.
On the test, so the number is 4. When you have to say composite, multiply or divide by 2, or will you just say composite?
Good question. I believe it's just prime and composite. You have to be able to say which one it is. But just know, if it's a composite, you need to know that it's divisible by other factors. It might ask you for that. If you know it's a composite, you'll know which one you can divide it by. I'll have to look that one up later. Any other questions on prime and composites? All right. CO22, prime factorization. So those prime factors, remember when we break it down to all the primes. So remember that prime factorization, we make the factor tree. So we're going to break the number down into all of its prime factors. So you can put the definition on there. You can put make a factor tree. Can we do an example of the factor tree? No, you can't put the example. We're going to go through it as a reminder, but you can't write the factor tree on what it looks like on your help sheet because we don't put examples on it. Marina?
So we can't even just make circles and then draw a line to remind us.
As long as there's no words or no numbers in it. So you could say make a factor tree. And you could do this. There's no numbers in there. You need to know how that gets filled in. So you could do this. So we remember what a factor tree looks like, but we can't put numbers into it. We're gonna do one. Let's do 40 as an example in class to remind us. Do not put this example on your help sheet. That's why I'm doing it in blue. What could I break 40 into? Ava?
10 and 4.
Yeah, 10 and 4. Are those prime numbers? No, I haven't found my primes yet, so I need to break it down even more. What can I break 4 down into, Marina? 2 and 2. 2 times 2 is 4, so I need to put both 2's on there. What can I break 10 into, Zelda?
You can break it into 5 and 2?
Yeah, 2 and 5. Can I break 2 and 5 down anymore? No. So now I'm at my primes. So my prime factorization is 2 times 2 times 2 times 5. So I take all of the primes, and if I multiply them together, I get 40. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. So that prime factorization is showing me what prime numbers do we multiply together to get our original number. Any questions on prime factorization? Ava?
Wait, would it be wrong if you could do 2 times 2 times 5 times 2?
No, because multiplication, it doesn't matter the order we multiply in, we get the same answer. So 2 times 2 is 4, times 5 is 20, times the 2 is 40. As long as you have the correct prime numbers, it doesn't matter the order we put it in. Good question. And remember, it doesn't matter what we break it down with to begin with, we'll end up with the same primes. I could have said 2 and 20. 2 stays a 2. 20 I can break into 2 and 10. So my 2 stays a 2, the 2 stays a 2, and my 10 I break into a 2 and a 5. I get the same primes. I might have started with a different factor buddy. My answer is going to be the same. So on the test, I'm going to want to see your work. Show me what factor buddy you're using and how you're breaking it down. All right. CO23, greatest common factors of a set of numbers. So what is the GCF? So the common factors. So when we see greatest common factors in our directions, we might see that called the GCF. The greatest common factors. Remember, factors are those factor buddies. We break it down to all the numbers we multiply together. People very often confuse the greatest common factor with the least common multiple. So you're going to want to put on here something that reminds you what greatest common factor is. So you might put something like factor buddies. So you remember to break it down into the numbers that multiply to that. So you want to make sure you remember what GCF means with those factor buddies. So when we want to find the greatest common factor, we could use different methods to get it. So think back to when you did this homework page. What helped you? Which method did you like? Did you like using prime factorization? Did you like using the listing method or the table method? Remember, prime factorization, you break down, let me do it in blue because we can't put examples on there, but you break it down, 3 and 6. 6 can be broken down into that 2 and 3, and then our 15, our 3 and 5. Greatest common factors, they share a 3, but they don't share anything else, so our greatest common factor is that 3. If we looked at 42 and 30, we're going to break down 42, 6 and 7. 6 can be 2 and 3, and that 7 stays a 7. For the 30, we have 2 and 15, 3 and 5. Here they share a 2 and 3 and a 2 and 3, so we multiply those together, and we get 6 as our greatest common factor. Liam.
On our help sheet, can we write down like an example of like what the table looks like without the numbers?
Without the numbers, just like for the factor tree, that prime factorization, I said you could do the circles and lines with no numbers. You can do the same thing for this objective. You could show without the numbers how you break it down. And then you might show that, hey, they share these two numbers, so we multiply those two numbers to get our answer. So you multiply any factors that they share together, only the ones that they share. Listing method. Remember, you want to list out all the factor buddies. So if you're going to do the listing method, you list all factor buddies and find the biggest one that they share. So remember that was for 25, for 40, 25 would be 5, 1, and 25, 40 would have been 1, 2, 4, 5, 8, 10, 20, 40. So the listing one, you list them and you find the biggest one that they share. That is their greatest common factor. You cannot do the example, but you could use your circles and lines to help you remember. Marina, why don't you come up to the step table, please? Table method. So remember, with our table method, you're going to see what can I take out of both the 21 and the 35. So I could take out not 3, I could take out a 7. 21 divided by 7 is 3, 35 divided by 7 is 5. Whoops, sorry, I'm jumping ahead. Let me do this a little bit cleaner. So we have 21 and 35. We take out the 7, we're left with the 3 and the 5. I don't have any other primes to take out. So my greatest common factor is that whatever primes you can take out multiplied together. I can't take out anything else, so that is my greatest common factor. Any questions on any of those methods? Doesn't matter which method you use, you'll get the same answer. All right, CO24. This time it's the least common multiple. Multiples are very different than factors. Remember, factors are what numbers we break it down into. Multiples are what we multiply up to. Your number times 1, your number times 2, your number times 3. Ava, go to the side table. You compare all of your multiples. And we circled the smallest multiple that they share. So there were different ways to finding that least common multiple. We could do the listing, where we might have 5 and 20, and we would list out all of our multiples, list them all out. Well, let's not do 20. Let's do 5 and 9, listing out 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5. List them out until you find the smallest multiple that they both go into. Or you could do that table method. So if we had 5 and 9, we pull out the multiples that they share. Let's not do 5 and 9 because they don't share any factors. Sorry, not multiples, factors that they share. So let's do see this one from the bottom. Actually, let's do 12 and 9. What factor can I pull out of, what prime can I pull out of 12 and 9? 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Can I pull any other primes out?
You can't pull any out of both of them, but you can pull 2 out of 4.
Yeah, I couldn't pull out of both of them. I could pull a 2 out of the 4. I couldn't pull it out of the 3, so I'd rewrite that. So when we are finding that least common multiple, we want to multiply together that L shape of primes. So all the primes on the left and all the primes on the bottom. So 3 times 2 times 2 times 3. So 3 times 2 is 6, 3 times 2 is 6, 6 times 6 is 36. So I know my least common multiple of 12 and 9 is going to be 36. 12 times 3 is 36, 9 times 4 is 36. That's the smallest multiple that they share. See a lot of people looking at classmates and not putting stuff on help sheets. Gonna tell you right now, least common multiple tricks people up all the time. Make sure you know what you're doing. Any questions on the least common multiple? Connor?
Do you know if there's going to be any questions on the test that you feel listing for? Or like, that's like, it just has to be.
You can always list. It just might go really high. You might have to list up, keep multiplying up to a higher number. But you can always do the listing method. Any other questions on those? All right. CO25, I can use ratios to compare two numbers or quantities. Wait, did I do yeah, I did 24. So a ratio compares a part to a part. So remember that ratio compares part to part. You can show that as a fraction, a colon, which is when we use the dot dot, or with words. It is important you know all three ways to a ratio. It is not, oh, whichever one I like the best. It's not one of those formulas on how to solve something. You need to know all three ways to a ratio. So you should write that down. Fraction, colon, or with words. Remember, when we work with our ratios, it goes in order. 10 to 15. 18 to 9. 25 to 40. 27 to 12. Doesn't matter the way we write it. We say it all the same way. And then to simplify, equals dividing both parts by the same number. Just like with fractions, whatever you do to the top, you do to the bottom. Whatever you do to one part, you do to the other part. And you go down as far as you can go. Sometimes you have to simplify more than once. Go down as low as you can go. Any questions on simplifying our ratios? Just like with our fractions, your final step when you write out your ratio will be to simplify it. So one section might just be straight up simplifying your ratio. But remember, we had other parts where we had to write the ratio. You're not done until you simplify it. So ratio of red marbles to blue marbles. There were 12 red to 16 blue. You can sit on the other side so you can see better if you need to. But this is not finished because I can simplify that. So that is not a final answer. That will be wrong if you said 12 to 16 on the test. You have to simplify. I can divide both sides by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Simplified answers are your final answer. So make sure you simplify. You could write that on your help sheet. Make sure to simplify, or even just write simplify. Simplify, simplify, simplify. Put that on your help sheet and circle it so you remember to simplify your answers. We don't want to have to retake an objective because we forgot to simplify. Any questions on the ratios? All right, next objective. CO26. I can identify, write, and find equivalent ratios with all three types of ratios, whether it's with the colon, with the words, with the fraction. You can find the equivalent ratio by doing what? Zelda?
You can simplify and multiply.
Yeah. So with CO26, multiply or divide all parts by the same number. Just like when we find equivalent fractions, what you do to one side, you do to the other. So you can either multiply up, divide down. There is not just one answer, because you can multiply or divide by lots of numbers. But it has to be the same number. Just like when we're simplifying down, we're dividing out the same number from the top and bottom. When you're finding the equivalent, you would say, okay, maybe I'm going to multiply them both by 2. 4 to 5 would be 8 to 10. Okay. Whatever you do to one side, you have to do to the other with your multiplying and dividing. Any questions on equivalent ratios? Got it.
So the bottom thing is there going to be like a max number of different numbers can go into one of them, or will the number be able to go into one of them, like a ton of them, or like all the numbers? All the numbers in the circle.
Yes.
Will they?
So we're not going to have like this homework thing where some of them had a given ratio that worked and some didn't. It'll be, hey, here's a ratio. Give me equivalents to it. Okay, it's going to be a little bit simpler. But we will have to know how to solve these word problems. So remember, for this one, we had girls to boys, 3 to 2, and then there were 15 girls. How many boys? Look at how I set that up. I labeled each column of my ratio. I put in my given ratio. I put in my known of the new equivalent. And remember, you would need to decide, how did I go from 3 to 5? I multiplied by 5. Sorry, 3 to 15, I multiplied by 5. So I need to do 2 times 5 to get that answer. What do we do if we can't see right away what to multiply up to? Who remembers? If we can't say, 3 to 15, I multiplied by 5, that's quick and easy. What do we do? I think that comes up on our next objective. So let's look at our next objective. Using rates and unit rates to compare numbers or quantities. So remember, this one, it wasn't always that easy. So when we're doing rates and finding the equivalent rates, we would say mowing 2 lawns in 3 hours. Okay, so we need to be able to take what they're giving us and then find an equivalent to it. What do I do to find an equivalent? Same thing as equivalent fractions, same thing as equivalent ratios. What am I going to do, Madeline? Multiply or divide by the same number. So an equivalent, I could say, okay, I'm going to multiply them both by 2. And I could say 4 lawns in every 6 hours. Multiplying and dividing by the same number. Whenever we're doing equivalent, you're multiplying or dividing by the same number. But down here we have the unit rate. The unit rate, we always have a denominator of what? What does our denominator need to be, Layla? A 1. So in order for it to be a unit rate, that denominator must be 1. So if we have 2 hours, what do we have to do to get it down to a 1? Zelda?
Divided by 2.
Divided by 2. So you're going to divide both top and bottom by the denominator if we have a whole number. Remember, if it is that fraction, and you're going to want to put this, multiply by the denominator of the fraction, because we want to get it to a 1. So when we have 1/4, we want to multiply it by 4, because 1/4 times 4 gets us 1. So when there's a fraction as your denominator, that's when we multiply it, so we get to that 1. If it's a whole number, we're going to divide it by that whole number. Whatever you do to the bottom, you do to the top. Okay? So you need to remember that. If you're dividing down that bottom, you have to divide down the top. Any questions on this? And if you're not finished writing, you can watch the video later to fill it in. So if we had, maybe it was the proportions that we have to do the funky. All right, proportions. So PO 28, this is our last objective. PO 28. So proportions, we want to make those equivalent ratios. So we're looking at those equivalent. We're going to see what we multiplied the top and bottom by to get to our missing thing. So here, if we have 2 cups for 3 batches, that is proportionate to 18 cups for 27 batches. We know that they are a proportion because we multiplied both sides by 9. Sorry, multiply both the top and the bottom by 9. So it's equivalent. That is a proportion. So proportion means equivalent. We're finding what we're multiplying or dividing both the top and the bottom by to make that proportion. So when we have a missing section to our proportion, we need to be able to find that. This is where we might not know what we multiplied by. This soccer goal one. In 4 games, we scored 10 goals. That is proportionate to, in 14 games, how many goals are we going to score? Do we know what we're multiplying the 4 by to get to 10? No, we don't know what we multiplied by. So how do we find that? Sorry, not 4 to 10. How we went from 4 games to 14 games. We don't know what to multiply the 4 by to get to our 14 games. So remember, that's when we divide it. We say 14 divided by the 4. That will tell us what we're going to multiply by. And it might be a decimal. So I believe it's 3.5. Yep. If we do 14 divided by 4, we get 3.5. So then we go back and we say, oh, I need to multiply by 3.5. 4 times 3.5 gives me 14. So 10 times 3.5 is going to give me my goals. Marina?
Are you able to use a calculator on it?
Yes, on this section you will. It's the beginning part where we need to know how to do the rules. This section, yes. But you need to know what you're multiplying or dividing by. So once you know how to do it, you can use the calculator to solve it. Right?
On that test, can we use a multiplication chart?
Yes, you can use your multiplication chart from your planner. That is fine.
On all of them? Wait, isn't it just the first one that we can't use our calculator on? Can we use it
I will go through it with you tomorrow, which objectives you can and cannot. It'll be the
on?
first sheet, no calculator. You tear that off, turn it in, then you can use the calculator on the rest.
Can you use the calculator on like the regular test, not the practice test?
You can't use the calculator on the practice test, you can't use it on the regular test. So that begin those first objectives, yeah, it's a no calculator on the practice and the regular. Any other questions? So, if we don't know what to multiply going up, we divide going backwards. There will be one like that on the test. You don't know how to multiply up, make sure you remember divide going backwards, and it'll tell you what you multiply by. 14 divided by 4 is 3.5. So 4 times 3.5 gives us 14. They go back and forth like that. Any questions on it? Okay, so we have a little bit of time before class ends. You can go through and look at some of those objectives. Please stop moving. Maybe you said, ooh, I totally forgot how to do this one. I need to review it. So do that. You can finish writing on your help sheet if you didn't finish your help sheet. You can work on your math packet that is due on Tuesday, due tomorrow. So Tuesday, math packet needs to be turned in, so if you need to finish that, you can work on that. Ava?
If you're staying after school, can we like ask you about?
If you have questions after school, yes, you can definitely ask me about it after school. Most definitely. If you are watching at home, I hope you are well. I hope to see you soon. Have a wonderful day.